Happy morning, students. Myself, Dr. N. Meenal, Assistant Professor, Department of Mathematics, JJ College of Arts and Science, Pudukkottai. Now, we are going to discuss a topic, symmetric matrix, for the allied paper, Allied Mathematics 2, for the courses BSc Physics and Chemistry. First definition, symmetric matrix. So, for a symmetric matrix, you have to take only the square matrix. So, you know what is a square matrix? In a square matrix, the number of rows and the number of columns should be equal. This is the square matrix. So, the first condition for defining a symmetric matrix is you have to take a square matrix. Number of columns and the number of rows are equal. So, that matrix is called symmetric if the transpose of the matrix is denoted by the symbol A transpose. If A transpose and A are equal, then that matrix is said to be a symmetric matrix. Let us take this matrix. This is a square matrix since the number of rows and number of columns are equal. So, if you find A transpose, how to find A transpose is you have to interchange the rows into columns. That is, let me find it now. The first row is ABC. You have to write it in the column wise. So, you have to write A, B, C in the first column. And the second row is B, D, E. You have to write it as the second column, B, D, E. And the third row is C, E, F. So, you have to write it in the third column, C, E, F. Therefore, I have found out A transpose by interchanging the rows into columns. If you compare this, you find that A transpose and A are the same matrices. Let me compare. In the first row it is ABC. Here also in the first row ABC. Second row BDE. In the second row here also BDE. In the third row CEF. Here also it is CEF. Therefore, this matrix is a symmetric matrix. So, for the symmetric matrix, the diagonal elements can be any numbers. No need to verify the diagonal elements. You have to verify only these elements. This BC must be the same here also. Similarly, E and E should be the same. If these elements are same, then we can say that that matrix is a symmetric matrix. The condition for symmetric matrix is Aij should be equal to Aji. This can be asked in a 2-mark question. What is the condition for a symmetric matrix? So, Aij. So, this row, this element in the position A11. Similarly, this element is in the position A12. This is in the position A13. First row, third column. Here, second row, first column. Second row, second column. Second row, third column. Here, third row, first column. Third row, second column. Third row, third column. So, always I represent the first number represent the row and the second number represent the column. So, A21 should be equal to A12. That is Aij equal to Aji. This is the condition for a symmetric matrix. Next definition is for skew symmetric matrix. This should also be a square matrix and it is called skew symmetric if its transpose, that is A transpose, is equal to minus A. Skew means you will be having a negative sign here. So, when you find A transpose, it should be equal to minus A. Or you can write in this manner also, that is A is equal to, minus can be put to the other side, minus A transpose. So, there will be a negative sign in the skew symmetric matrix. A skew symmetric matrix should be in this manner. That is, all the diagonal elements should be 0, because you should have a negative sign. So all the diagonal elements should be 0, and these numbers should be given in a negative manner here. Then only you get A transpose is equal to minus E. So there we find the element should be repeated here, but here there should be a negative sign. And keep it in mind that for a skew symmetric matrix, all the diagonal elements should be 0. Now let us see the properties of skew symmetric matrix. Here Aij should be equal to minus Aji. So there we have plus sign, here we have minus sign. This is the first property of a skew symmetric matrix. And the second property is all the diagonal elements should be 0. This is the second property. Next, very important theorem. The statement of the theorem is, any matrix can be written as a sum of a symmetric matrix and skew symmetric matrix. This is the very important theorem. Based on this theorem, we will be doing problems. So we will be given a matrix, A matrix. To write it as a sum of symmetric and skew symmetric matrix, we have to find A plus A transpose by 2. This is a symmetric matrix. And you have to find A minus A transpose by 2. This is a skew symmetric matrix. If you add these two matrices, you will be getting a matrix. This is the problem we are going to do. We will be given a matrix and we will be finding A plus A transpose by 2 and A minus A transpose by 2. And when you add these two matrices, you have to get the original matrix in the given problem. Let us do one problem in this manner. The first problem is, express the following matrix as the sum of a symmetric and a skew symmetric matrix. So the matrix given is minus 1, 7, 1, 2, 3, 4, 5, 0, 5. So we have to take the given matrix as A. So here they have used A dash. You can write A dash for A transpose, or you can even write A power T. Both are one and the same. So we have to find these two matrices and you have to add and get the same matrix as A. So first let us find A plus A transpose. So here you can write it as transpose. So you have to write the given matrix. For the transpose, you have to write the row wise elements into column wise. So I have interchanged and written in the column wise. After finding A transpose, you have to add A plus A transpose. So minus 1, minus 1. When you have 2 minus sign, you have to add and put a negative sign. Therefore minus 2. When you add 7, 2, you get 9. 1 plus 5 is 6. And 2 plus 7 is 9. 3 plus 3 is 6. 4 plus 0 is 4. Then 5 plus 1 is 4. 5 plus 1 is 6. 0 plus 4 is 4. 5 plus 5 is 10. So now we have found A plus A transpose. Then you have to divide by 2. Here is a 2 in the formula. So you have to divide by 2. When you divide by 2, you get minus 1, 9 by 2, 6 by 2 is 3 and 9 by 2, 3, 5, 3, 2, 5. Then you have to find A minus A transpose. So you have to put a minus sign here. For A transpose, you have to interchange the rows into columns. Then you have to multiply the minus sign inside. So here you get plus. When you bring the minus sign here, minus will become plus and all the plus terms will become the negative terms. So you have to put minus. 0 is neither a positive number nor a negative number. So you have to put 0 as it is. Then you have to add these two numbers. When you add these two numbers, the result will be minus 1 plus 1 is 0. 7 minus 2. When you have a plus sign and a minus sign, you have to subtract and put the bigger number sign. 7 minus 2 is 5. And the greater number sign is plus. 1 minus 5 is 4, but you have to put minus 4 because the bigger number is minus. 2 minus 7 is minus 5. 3 minus 3 is 0. 4 plus 0 is 4. 5 minus 1, you get 4. 0 minus 4, minus 4. 0 minus 4 is minus 4. 5 minus 5 is 0. This is the answer for A minus A transpose. Let me show you in the next page. So this is the answer, and you have to now divide by 2. So you divide by 2, you get this answer, and you have to add these two matrices which we obtained. So this is the matrix A plus A transpose by 2. This is the matrix A minus A transpose by 2. Now you have to add minus 1 plus 0 is minus 1. 7 plus 5 by 2. How to add 9 by 2 plus 5 by 2. You have to add 9 by 2 plus 5 by 2. So 9 plus 5 is 14. 14 by 2 is nothing but 7. 14 by 2 is equal to 7. Then 3 minus 2 is 1. 9 minus 5 by 2. 9 minus 4 is 5 is 4 by 2. 4 by 2 is nothing but 2. So you get 2 here. 3 plus 0 is 3. 2 plus 2 is 4. 3 plus 2 is 5. 2 minus 2 is 0. 5 plus 0 is 5. So we have written the matrix A as the sum of symmetric and skew symmetric matrices. Thank you students for watching my video.